Boleh pakai untuk keod.
Ini yang satu. Mengambil
Tekan bu.
orang itu pemandangan itu kali baru kali kemudian tubuh ini punya kopi cara
Twelve students are going. Let's wait for 1 to 2 minutes. Then we start the lesson. Okay, students. So let's start the start to calculate this example. Acquire solution having. One second. P gives Q occur in isothermal conditions and rate reaction R of P is equal to KCP. And we can also write down KCP0 1 minus XP. We can write down like this. And feed rate V is concentration 500 centimeter cube per minute. And initially, CP0 is equal to 1.5 multiplied by 10 raised to minus 4 mole per centimeter cube. Barabar? And the volume carried out in volume is equal to 5 liter. Conversion XP is equal to 60%. It means 0.6 or 60%. Done? Okay. And ultimate goal is to find out. Ultimate goal is to find out K value. So CSTR having tau divided by CP0 here, XP divided by minus R of P. So XP divided by K CP0 1 minus XP. CP cancel out. So tau is equal to XP divided by K 1 minus XP. We can say K is equal to XP divided by tau 1 minus XP. So we can find out K. Tau is equal to volume divided by volumetric flow rate. Then tau is equal to volume divided by volumetric flow rate. Volume is equal to 5 liter and volumetric flow rate is equal to 500 centimeter cube per minute. 500 centimeter cube per minute. So can we find out in liter per minute? 500 centimeter cube per minute is equal to how much liter per minute? Can you say it in chat box? $500 centimeter cube per minute into the how much liter per minute? Can you write down in chat box? Okay. 0.5 liter per minute. It's 0.5 liter per minute. Then 500 centimeter per minute is equal to 0.5 liter per minute. So 0. Per liter per minute. So five divided by 5 multiplied by 10 minute. So it's 10 minute will be the space time. So K is equal to XP means 0.6 divided by 0.6 1 minus 0.6 multiplied by 10. 0.6 divided by 0.4 multiplied by 10. Can you tell me what is 6 divided by 40? What will be the sixth? Can you write down your answer in chat box? Okay, it's 0.15. 0.15 rate constant first order, so it's minute inverse. Any answer will be there in 0.15. Yes, B will be the option. B will be the option. 0.15. Then so we get a answer B. Now another question. 5 liter CSTR is replaced by 5 CSTR in series. If the capacity of each new CSTR is 1 liter, so every CSTR having capacity 1 liter, volume is equal to 1 liter, then overall conversion is in percentage. So we said that we have one equation, 53 number questions. 1 divided by 1 minus x5, because 5 CSTR, 1 plus k tau I raised to 5. Then ultimate goal is to find out x5 tau. Now tau will be the difference, because now volume divided by volumetric flow rate, each having 1 liter. Each having 1 liter, and volumetric flow rate is equal to 0.5 liter per minute. So space time is equal to how much? 1 divided by 0.5. It means 2 minutes. Space time will change from 10 minutes to 2 minutes, because now volume is 1 liter. It's not 5 liter. One divided by 1 minus x5 is equal to 1 plus k value we have how much? 0.15 multiplied by space time 2 multiplied by 2. So can you tell me the value of x5? X5 is equal to 73 saying Mukesh, 73 saying Paras, 40.82 will be the Dharmic, 73 and 48. Let's see what will be the correct answer. Okay, it's 73 per 73 is the correct answer. 73 will be the correct answer. Then, so let's see whether we have a option 73 is correct or not. Yes, C will be the correct option. 73%. Then, so it means 1 5 liter one CSTR having 5 liter series, 5 liter capacity, and its a and its conversion is 60%. I think yes, 60%. Instead of it, if I take 5 CSTR, 1, 2, 3, 4, 5, and H having 1 liter, then at the end X5, your conversion will be 73. It means 13% conversion is increases if we divide this uh, if we divide this 1 into the 5. And what will the reason behind it? How this 13% conversion is increased? How? The reason behind it, here you say only one time mixing will be there, so two molecules are transferring the electron having maximum capacity. Here it will transferring electron, here transferring electron, here transferring electron. It means that there 5 times we are giving a treatment. Once we are giving a 5 time treatment, it gives me the better concentration decreases. Here why it is conversion increases? Because the concentration decreases very much faster. It is too much concentration decreases. Because of that reason, because why concentration is decreases? Because we are giving 5 times treatment. It's not one time treatment. If we give 5 time treatment, then concentration decreases more compared to one reactor. And because of that reason, 73%. Because of that reason, 13% conversion is increasing. So it's good if we multiply 2 CSTR, 3 CSTR, 4 CSTR in series. But ultimately also we have to the maintenance of this file is also a very difficult one. Compared to this one, if the maintenance is very difficult to maintain file. એકને હેન્ડલ કરવું ઈઝી છે, બટ 5 ને હેન્ડલ કરવું ડિફિકલ્ટ છે. બટ એની સામે તમને 73% કન્વર્ઝન બી આપે છે. So that is the ultimate goal. That is the things that I would like to give the knowledge, or I would like to give the fundamental regarding this one. Are you convinced with this? You understand this concept? You understand this concept? Yes, conversion is increased 13. Are you understand what happening this? Yeah? Okay. A very good example. So now we go further, and we end this equations here, and we'd like to go further, and I would like to give a very good fundamental equation using this one. So we last stop here. This equation C0 divided by Cn is equal to 1 divided by 1 minus xn is equal to 1 plus k tau raised to n, where n represent number of CSTR, k represents space time, k represent rate constant, tau represents space time, xn means conversion at after the 5th day, C0 initial concentration, Cn is a concentration after the nth day. Now what I will do, now we go further. We'll do something in this equation, and I would like to give a very good fundamental concept behind this. So let me go further. Okay, this is the equation that we end here. Now I would like to go deeper into this. Let me do this. If 1 comes here this side, then I can write down C0 divided by Cn minus 1 is equal to k tau I. Here k tau I. So once this come here, okay, and oh sorry, let we I'm go straightforward. If we can also write down this, if we do the arrangement after arranging above equation, then we can write mass value tau n space time for n reactor is equal to n multiplied by number of tank multiplied by space time for each reactor. Space time for the nth reactor is a number of the tank multiplied by Ti. We can write down this one is equal to n multiplied by k is equal to C0 divided by Cn raised to 1 divided by n minus 1. We can rearrange these equations like this also. Ultimately tau n is equal to, we can write down like this if we rearrange this one. Now now I would like to just see it, and what I would like to say, for examples we have a equation for CS for PFR, T divided by C0 is equal to 0 to XA divided by minus RA, or in other words the K CA0 1 minus XA, or let me write down this one, K multiplied by CA, or K multiplied by CA. Just here CA, so above one I have to give the CA, so let me write down, it's like this, tau divided by CA0 BCA divided by KCA, and I change the limit from CA0 to CA. So if I do tau divided by C0 is equal to 1 divided by K, 1 divided by C, it means K ln CA integration CA0 to CA. So if I do the integration and final answer, just final answer, I can write down 1 divided by K ln CA0 divided by CA. I can write down like this equation in this format. Finally, it means uh, if I do the first order if I introduce the first order systems in PFR, and after doing the integration, I'm getting this equation. Maybe I did in steps, but the final first order systems in PFR. First order in PFI, I finally get this one. Now, uh, if I put in these equations, if I put in these equations, n tends to infinity. I put these equations, n tends to infinity. So if I put n tends to infinity of above equation, then can you tell me the answer? If I put n tends to infinity, then what this equation becomes? If I put 10 n tends to infinity, then can you reduce this equation and can you tell me the answer? Infinite here, infinity divide infinity c0 divided by c infinity 1 divided by infinity minus 1. Uh, can you reduce this one and can you tell me the last answer? If I introduce, if I put infinity here, n tends to infinity, and what is the answer if I reduce it? Any, can you tell me the answer? Dharmik, it's a direct answer. Maybe I give some, I did some wrong calculation, but the final answer, if I give the first order systems in a plug flow reactor, then finally I'm getting the answer like this. Now, can you tell me if I put n tends to infinity here, then what will be the correct equation? Can you reduce that equation? Can you write it down? Anyone will tell me what if I put n tends to infinity and how if we reduce this equation, then this one, yes, using this one, yes, using this one, you are getting this one. If I rearrange, this one will be the here, then n will be the above one, so it becomes 1 divided by n. It's nothing but the rearrangement, and then they are getting the answer. So 1 will be the here, so c0 minus cn minus 1. So here they are replace n, here they replace n, and then k will be the here this side. So 1 minus sorry, it's like a c0 divided by cn minus 1 is equal to k tau raised to n. So they are removing this n from here, so they are introduce the n here, so c0 cn raised to 1 minus n divided by n. So they are become the n is equal to k tau I. So finally c0 divided by cn raised to 1 minus n minus 1 divided by n divided by k is equal to tau. So I think they rearrange like this one and they are getting the answer from this one to this one. Tau I is equal to tau n કેવી રીતે લીધું? If I say it's a uh, if I take any for example space time for the nth order is equal to number of tank multiplied by the uh, 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 space time for the each reactor. Let me see one more time. I will go into this and then we'll give the answer. Can you give me one day for this one? So students, what finally I would like to say, if I introduce n raised to infinity here, if I take n raised to infinity here, then I can reduce this equation like this. Tau is equal to 1 divided by k ln c0 divided by c1 or something. Remember? So what is the meaning of it? What that the final thing I would like to tell, the final conclusion. If I put one plug flow reactor, the final conclusion, final fundamental, that is the thing. If I have a one plug flow reactor and whatever the conversion I am getting here, x, for example, 80%, then instead of it, if I put n CSTR, or I've said infinity number of CSTR, then I'm getting the same conversion 80%. If I take one plug flow reactor and if I getting the infinity number of CSTR, then I'm getting the same answer. If I am getting, for example, okay, one plug reactor, it's 80%. If I take 2 CSTR, then maybe I am getting, maybe I'm saying it's a 70%. If I take 3 CSTR, then I'm getting the answer conversion will be 75%. 4 CSTR, I am getting 76%. 5 CSTR, I am getting 77%. If I take infinity number of CSTR, then I am getting the exact. For example, I am taking 1000 CSTR and maybe I am getting 79.97 or something. But exact answer I am getting 80 whenever I put infinity number of CSTR. So if I take one plug per reactor, instead of if I take n CSTR, both are having the same answer. But the infinity of CSTR is not possible. But maximum number of CSTR we are getting very close to very plug flow reactor. That is the final message I would like to tell. It means that if I take a first order reactions within the plug flow reactor, and if I take n number of tanks within the first order reactions, and if I take both equations similar, it means instead of plug flow reaction, if you use n number of CSTR or infinity number of CSTR, I'm getting the same answer. Number of CSTR less, conversion is less. So that is the final things that I would like to tell. This is the final. Then this is the final fundamental that I would like to tell you regarding this n number of CSTR. Now we'll calculate one example based on it in next class. In next class, what we'll do, we'll calculate one example and we'll try one plug flow reactor will instead of 5 CSTR then this type of we'll calculate one example in next class. Yeah? Let me first say which one will be the example. So just stay 5 minutes. Within 5 minutes, I would like to just paste the example. Okay. Just two linked example. The example say first order liquid phase reactions A gives P in isothermally plug flow reactor, and plug flow reactor volume is 5 liter. Initial volumetric flow rate V0 is given, CA0 is given, exit concentration CA is given. So initial and exit both are given, and they ask us to calculate rate constant for plug flow reactor. Now, if I say one plug flow reactor replaced by 3 mixed flow reactor in series, each having 2 liter volume, then what will be the exit conversion CA? Sorry, what will be the exit conversion of A? It means what will be the XA value. So it is the example related to what we did theory right now. We'll calculate this example in next class, and let's see how much we are getting once if I replace CS one plug per reactor with 3 CSTR. And with this I end this lecture. Anything you would like to tell me, just unmute yourself. Otherwise, if you don't have any question, then you can leave the class or you can leave the meeting. We'll calculate this example in next lecture, and then we'll start unequal size of CSTR in series in next lecture.